Continue joining. I can see you. Continue joining the link. You can also share with a friend. We're going to look at a paper 1 question. That is a differentiation. And also another question from a scale drawing. Yeah, welcome. The lesson is here with us. Finally, the lesson is here. I had promised to cover differentiation and also scale drawing. So much welcome. Invite a friend. You can just share the link with a friend. Yeah, we can now get started. We are given a question here, number 23. The equation of a curve is y equals to x minus 2x squared minus 1. Determine part 1, the stationary points. Another name of stationary points is the turning points. So the examiner can use that alternative language to just mean the same. So it's good you be aware that stationary points are also the turning points to a given curve. Now, what should be noted is that at the turning points, gradient of a curve is usually 0. Gradient equals to 0. The gradient is usually given as the differential of the function y with respect to x. So when we differentiate y with respect to x, we get the gradient function. Then the gradient of a curve at the turning points is usually 0. So that is something to be understood. So we now differentiate this function, the function of y with respect to x, dy dx. So this function now becomes, we have x power 3, so we drop the 3 here. Then we have x, the power reduces by 1, so it becomes squared. The other one is negative 2x squared, so the 2 drops to this side and we will have a negative 4 and x remains like that. Then the constant here, remember at a constant, there is x, only that x is to the power of 0. And when something is raised to power 0, it becomes 1. Therefore, negative 1 is having a x, which is to power 0. Therefore, the power we are dropping in this case is a 0. That is why every time sound, just check your gadget. My sound is okay. Somebody is telling me sound, please. Somebody is saying sound, please. Kindly check your gadget. My sound is okay. So whenever we are differentiating a constant, there is usually the variable, but raised to there is usually the function, there is usually the variable but to power 0, which means if the 0 drops to this side now, the constant becomes 0 and it disappears. So this is the differentiated function. Now, at the turning points, this function will be equal to 0. So that means 3x squared minus 4x is equivalent to 0 at the turning points. And now we can solve this quadratic equation. In this case, we can factorize x to remain with 3x minus 4 equals to 0. With 3x minus 4 equals to 0, we can now get the value of x. X is either 0 when we equate this part to 0, or the other factor here to 0, or 3x minus 4 equals to 0. 3x minus 4 equals to 0. That means x will be equal to, we will have 4 to this side, becoming positive. 4 becoming positive, then we divide. Then we divide by 3. So it will be 4 out of 3. Or rather, we will have a 1 and a third. We will have 1 and a third. 1 and a third. So we have two values of x. 0, 1 and a third. Now the turning points are coordinates. The turning points are coordinates. So we should get the value of y at those values of x. Therefore, I need to substitute 0 in the original equation, which will give me the value of y. Therefore, when we substitute 0 at x equals to 0, the value of y will be negative 1. Therefore, the turning point now is 0, negative 1. That is a turning point. The next turning point is when x equals to 4 out of 3. Therefore, we can have now y being given by x cubed. So 4 out of 3 raised to power 3. Then minus 2 into 4 out of 3 squared. Then minus 1. So the value of y is going to be negative 2.18. When x equals to 4 over 3, the value of y will be negative 2.18. So in this case now, we will have the coordinate as 1 and a third, negative 2.18. So that is the second coordinate of a turning point. So we have our two turning points. The next now is determining the nature of the stationary points. Above. Now that we have the stationary points, the other thing is to determine their nature. So we need some values of x, then the value of the gradient. So I will prepare a table here which will guide us into knowing the type of turning points we have obtained above. So we can start with the first one as x equals to 0. So we can begin at just before x equals to 0. We can have x at minus 1. Then x at 0. And just after the 0, we can have 1. Then for the second one, we can have 1 and a third, or rather 4 over 3. then just after 4 over 3, a point like 2, So we can get several values of the gradients now, and in this case, we will need to say that at -1, the value of the gradient, because we have gradient function, the value of gradient is going to be, we begin with 3, then -1 squared, -4 into -1. So this is going to give us exactly 7. That is giving us exactly 7. In the next, when x equals to 0, the gradient is also 0. That one we know. But now, after this point where x is 1, where x is 0, at 1, what will be the value of gradient? So we'll have 3 into 1 squared minus 4 into 1. This gives us -1. Therefore, for the stationary point, which is at x equals to 0, we have this variation. Let me now illustrate it. We have this variation such that the gradient before the point itself, gradient is positive. This is how a positive gradient behaves. Then at the point itself, gradient becomes 0, so it flattens. But after the point, the gradient becomes negative. So we will have it sloping like this. So that is how the gradient behaves at that point. And we can confidently now say that the coordinate 0, which is a turning point, -1, is a maximum point. This is a maximum point. This is because the gradient is behaving such that it is turning from positive through 0 to negative. So this is how the turning point is behaving. The turning point is behaving in a manner. That is how the turning point is. So it's a maximum point. We have the other turning point, whereby at the turning point, which is 4 over 3, the gradient is 0. But just before the turning point, the gradient is 1, which means it's -1, which means the gradient is negative. At the turning point itself, gradient becomes 0. Then at 2, we can substitute in the equation and see what the gradient becomes. So we will have 3 into 2 squared minus 4 into 2. This gradient becomes positive because I'm getting a 4. Gradient becomes positive. This means now, because it is positive, now this kind of a point is turning from negative through 0 to positive. This is to tell us that 4 out of 3, -2.18, is what we call a minimum point. So this is a minimum point. This is a minimum point. A minimum point. So that is how the minimum point is identified. So we have a turning point, which is a maximum, and another one, which is a minimum. The second part is telling us to, part B, to determine the equation of the tangent to the curve at the point x equals to 1. So at x equals to 1, we need to know gradient. So we need to know the gradient. dy dx will be equal to 3 into 1 squared minus 4 into 1, because the gradient function is already identified as 3 into x squared minus 4x. Therefore, the value of gradient at x equals to 1 is -1. So that is the gradient. And now we need also to know the value of y at x equals to 1. the value of y. Therefore, we need the original function now to give us the value of y, this original function here. Therefore, we will need 1 cubed minus 2 into 1 squared minus 1. So this becomes a negative 2. So the value of y is a negative 2. Therefore, now we have a coordinate 1, negative 2, and a gradient of negative 1. Then with a gradient of negative 1 and the coordinate 1, negative 2, we need to get the equation. The equation of the tangent is calculated using the concept of equation of a straight line, knowing that at a given point, the gradient of the curve is equal to the gradient of a tangent at that particular point. Therefore, we need to say gradient, which is negative 1, is given by, we take another point to be xy, just like a normal line, because a tangent is a line, y minus negative 2, then divided by x minus 1. So now we can cross multiply. We will have y plus 2. We'll have y plus 2. Then this is equal to negative x by negative 1 by x. Get negative x. Then negative 1 by negative 1. It becomes a positive 1. So we can remain with y at this point. And this will be equal to negative x minus 1, because 2 becomes negative at this point. 1, negative 2. So this is the equation of the tangent at that particular point. The next is telling us to find, the equation of the normal to the curve at point x equals to 2. So at x equals to 1, the value of y, we've just identified it as negative 2. Then now, a normal is usually perpendicular to the tangent at that particular point. So that means if the gradient for the tangent is negative 1, then the gradient for the normal is going to be positive 1, such that when the two gradients are multiplied, we will get a negative 1. Therefore, we use a gradient of 1 and the coordinate, which is 1, negative 2, and we let another coordinate now, xy. Remember, in the evening, we'll be handling physics paper 2. Kindly make sure you also turn up for the same. So we're going to have 1 being equal to, change in y minus negative 2, y minus negative 2 out of x minus 1. So when you cross multiply, you will have a y plus 2 equals to x minus 1. Then we arrange now the equation to take a right format. Y equals to x minus 3. X minus 3. So this is the equation for the normal at that particular point. So now we can get to a question here on what we call scale drawing. The boundaries of a range A, B, B, C, C, D, and D, A are straight lines such that B is 0.75 degrees from A, 0.75 degrees from A, and a distance of 50 kilometers. C is due east of B, and a bearing of 80 degrees from north to east. This is called the compass bearing from A. D is due south of C, and a distance of 70 kilometers. A distance of 70 kilometers. And we are told, using a scale of 1 centimeter to represent 10 kilometers, show the positions of A, B, C, and D. So we're going to come up with a scale diagram, which will help us to know those positions. Before we come up with the real scale diagram, we can just have a sketch. this information. Being told that B is 0.75 from where? From A, a distance of 50. So if this is taken to be our A, then we will need a bearing of 75. A bearing of 75. Then we reach where B is, and 5 centimeters, since we are using a scale. The other one is C is due east of B. So due east of B, it is to the right. So while at B, we just move to the east. And due to the east of B, and a bearing of from the north, we turn 80 degrees to the east. From the north of A, we turn 80 degrees to the east, towards east. So we just prolong this until where the two will meet. And that will become our C. Remember, it should be east of B and 80 degrees from the north towards east of A. So where the two instructions will meet, they will give us our C. Then finally, D is due south of C. So when you are at C, you just move southwards, which means from C, we just move downwards. And again, we should know that due south of C and a distance of 70. So 7 centimeters instead of those kilometers. And we will find our D. We're going to find our D. So roughly, this is how the positions are going to be. That is how they are going to be. So I can begin by identifying a point, and we call it A. This is our point A. Therefore, we need 75 degrees. I hope you've read the question. B is 75 degrees. 0.75 means this is a true bearing. 0.75 from A. That means we are going strictly from the north. 75 degrees. So from the north, I measure 75 degrees. This is the point. Then now I produce the line for 75 degrees. 75 degrees. Then now I need to measure, instead of 50 centimeters, instead of 50 kilometers, just 5 centimeters according to the scale. So 5 centimeters. 5 centimeters. I lift this distance and I make an arc. That is 5 centimeters. And now that we had measured an angle of 75 on this side, I can measure another 75 on the lower side so that I may produce a parallel compass to the first one. So I'm going to measure another 75 on the inner side, such that now that this is 75, with another 75 on this side, the two knots are going to be very parallel to one another, and that increases my accuracy. So now, after identifying where B is, I need to know where C is. C is due east of B. So while at B, we just move to the east. We just move direct to the east. So I'll move direct to the east. direct to the east by making an arc here. Then I produce a line that is to the east, to the east of B. So I'll follow this line, and also 80 degrees. 80 degrees. This is the instruction. North, 80 degrees towards east, which means that is from A, which means at A, I'll move from the north 80 degrees towards east. So from the north, 80 degrees towards east. So 80 degrees is at this point, 80 degrees. So I'll need now to produce this 80 degrees. So you see now, 80 degrees northeast of A and east of B, they are intersecting at this point. That means now I can produce my north at this point. Can produce my north at this point, and this will be my C. This is going to be my C. Therefore, point C is going to be at that intersection. The next point is D, and we are told that D is due south of C, a distance of 70. So from C, we just move downwards now. From C, we just prolong downwards. And instead of 70 kilometers, I'll just need 7 centimeters. So I'll need to stand here and I measure 70 centimeters. 70 centimeters. So standing at C, this is where 70 centimeters are. 7 centimeters for 70. So this is the point now. This is the point. That is the point D. So I have now my 4 points. I can actually join them. Okay, there are more questions now to be answered from this diagram for the relative positions. There are more questions which can be answered from this, and a few of them, I can just show you a few of them, which using the right diagram you can respond to later. From the scale drawing, determine the distance in kilometers between B and C. Between B and C, which means you just need to measure this distance in centimeters, then you multiply by the scale, which is 10. You multiply by the scale, that is how we get the distance. The next will be the bearing of A from D. The bearing of A from D, which means we will measure the angle from D. So at D, we just need to measure either the true bearing by measuring the angle from the north all the way until we connect with D, from D all the way until we connect with the line taking us to A, or simply we measure the angle here, measure the acute angle here. We can actually do this one. We measure the angle there. This is going to be 52. Yeah, 52 degrees. Therefore, from D to A, we have 52 degrees. And remember, we are moving from the north towards the west. So this is called compass bearing. North, 52 degrees towards the west. That is the bearing of A from D. Otherwise, we can get the reflex angle, which will be 360 minus 52. This is 380 degrees. 308, sorry. So 308 degrees. This is called the true bearing. The true bearing, which has to be measured from the north in the clockwise direction. This one is the compass bearing. the compass bearing, which is measured either from the north or from the south, and it has to be an acute angle. So those are the two bearings. Those are the two bearings. Okay, we can have another question from the same. The shortest distance from A to the border CD. The shortest distance from A to the border CD. So from A to the border CD, it means a perpendicular bisector dropping a perpendicular from A to the line DC, because the shortest distance between a point and a line is a perpendicular line from the point to the given line. Therefore, we need to draw a perpendicular standing at A to CD. So I can elongate my CD, use my ruler. I can elongate my CD so that I may draw the perpendicular very well. So I would need to stand here. I make an arc and an arc. Then I elongate the radius. I make an arc once again and an arc once again. So this will be a perpendicular now from A to the border CD. And this will be the shortest distance. Yes. This one now. So the shortest distance from point A to the border CD is going to be a perpendicular dropped from A to that borderline. Now this one can be measured in centimeters and you multiply by the scale. You multiply by the scale. Then lastly, you're told to calculate the area of the range in square kilometers. Therefore, you just take all the distances and you can divide it into the respective shapes. Then you come up with the area of the square, the area of the range, that is the area of the range bordered by the given borderlines. So thank you for following, subscribe and share.